So what is fermentation? I think all of you all must be familiar about the fermentation term. This term is derived from Latin term, that is the fervere. Its literal meaning is to boil. It was not actually boil, but due to release of CO2 bubbles during the process of fermentation by the microbes we use. We can use yeast, bacteria on the media. This process is undergoes through aerobic and anaerobic conditions both. So this is the fermentation. Now bioreactors, actually fermenter is a type of bioreactor where the microbial fermentation takes place and production of certain metabolites, certain products performed. So bioreactor is consist of several parts, like as we see in the PowerPoint that there is several kinds of outlet and inlets. First is the microbes, inlet of microbes, air, nutrients in the form of media. There is in middle, there is the shaft or paddle. It's actually a steerer, which steer the media and the biomass during the process of fermentation, which is moving at 50 to 100 RPM. Thereafter, the gas outlet and heating cooling jacket is covered around the fermenter chamber. Thereafter, all these temperature inside the media and the pH, these are already controlled by computer, which is already connected through several sensors or electrified mechanisms. So we can find, we can see that what is the temperature, because during the fermentation process sometimes the temperature becomes increased, and if temperature will increase, then initially it will help the microbes, but if become higher, then it will alters the growth, alters the metabolite production. So we control the temperature by cooling using this cooling jacket through which water is flowing. Another parameter, pH, is also controlled through this, and several other parameters are there, which is we are coming next slides. So it's a basically closed metallic basin which has adequate arrangement for aeration, mixing of media, agitation, temperature, pH control, and so this is the basic structure where we control these parameters. Now, the most common type of fermenter which is used for the production of metabolites or certain kinds of products is the stir tank bioreactor. It's nothing but there is a stirrer. The stirrer, as we see in the back slide, that this is the stirrer, this is the shaft. This is of different kinds. Sometimes it's oval, sometimes it's round, sometimes it's like cubical, spherical, like that. So the stir, its role is to stir, is to mix up the biomass, so that the aeration, agitation will be carried out. Now, here we see that high density of metabolically active cells in the medium can result in certain degrees of velocity, creating anaerobic condition in the medium. So proper oxygenation for proper aeration, we need this. Thereafter, to pH, which can also create problem, because during the process of fermentation, several kinds of products released that can change the pH. Thereafter is the rapid growth. Also results in the depletion of essential nutrients that directly lead the growth and metabolism. If there is less substrate or less amount of essential nutrients, means the production will be also less. And in lab there are 10 to 100 liters of volume of used in lab, using several nutritional parameters for better growth of cells. Now come to the next slide. The main function of the fermenter is to provide aseptic condition, to provide aeration, agitation, to provide low power consumption, temperature, pH should be controlled, and the facility related to this controlling should be available. Cheapest material should be used for the production. These are the structure, the design. Now, the criteria for the most efficient media. The media should produce maximum yield of product or biomass per gram of substrate used. The media should permit the maximum rate of product formation. The media should be cost effective. Cheaper media we use generally. Most commonly methanol we use, since it's mostly cheaper, so that the cost of the product should be minimized. There should not be any undesirable products, or we avoid production of undesirable products. Now, the basic process, how this is carried out. First of all, we take the stock culture. We take from a stock culture, we activate the cells from if you have it stored at 4 degrees C, and we first mix up in a seed fermenter where all the medium or nutrients are added, which is suitable for that particular microbes, and then it is added. It will be added in the fermenter. After the completion of fermentation process, the culture fluid, the biomass and broth both are separated, and the product will be collected through downstream processing, and the cell can be used for further next operations. Now, how this process takes place inside the fermenter. Now come to the fermenter, that how microbes grow there. So there are basically 4 stages. You must be familiar with the microbe growth in microbiology also. The similar thing is here. The first is the lag phase, second is the exponential or the log phase, third one is the stationary, and thereafter the death phase. So what is basically happened there? This is the lag phase. Lag phase here. Lag phase is basically the phase of adaptation. Suppose a particular organism is brought from hot place to directly to cold place in Antarctica. What will we do? That organism will do. That do first adaptation. How to adapt? How their body should compete with the atmosphere of the coldness. So this is the phase of adaptation. There is no cell division, only increase in cell mass, means volume of the cell will increase, size of the cell will increase without any division. So this phase depends on the type of inoculum or the age of inoculum. If the inoculum is young and healthy without any contamination, means lag phase will be smaller. It will grow faster. Thereafter, so this is basically phase of adaptation. There is also a depletion of media, but they first achieve their own growth. Now, what is batch culture? This is first. There are three types of cultures basically, or it's 4 or more than that. But the first is the batch culture, second is the fed batch, third is the continuous. There are basically three types. ऐसे तो फोटो बायोरिएक्टर भी हैं बहुत सारे, और भी पल्स रिएक्टर भी हैं, ऐसे fluidized bed भी है. But here we discuss about three only. Batch culture is a closed type of culture system where if once we added the media and the inoculum, and after growth, after the incubation period, it will be opened. No addition of any media during this period. Only after completion of the incubation period or the design product formation period, we can do downstream processing or further separation of the product. So this is the batch culture. Now after the lag phase, there is second is the log phase, log or exponential phase. In this phase, yeah.
So in batch culture, what is the meaning of limited amount of nutrients? Means we provide.
No, not limited. Limited means that whatever you have added in initial condition, that is the ultimate, because we can't add further during the process. So it will become limited now. Okay. Now come to the log phase. In this phase, cell population.
So means कि हम एक बार में ही जो एक ऑप्टिमल क्वांटिटी में चाहिए होगा वो ऐड कर देंगे.
हाँ, स्टार्टिंग में.
ओके ओके.
इसके बाद सेकेंड स्टेज इज द exponential phase. In this phase, cell population increases logarithmically. Maximum rate permitted, here cell division starts, cell multiplication takes place. The rate of nutrient depletion is also at higher rate, at maximum rate. In this stage, the cells of different age groups are present, and so this is not homogeneous. Certain cell will be very young, certain cell will be older, certain cell will be of recently budded, like that. So it's not homogeneous. So during log phase, consumption of nutrient will be maximum. Output excretion of the product will be also higher. Here the equation is the dx by dt. It's actually the rate. A rate, what is rate? Rate is the rate of the formation of the product, where x is the concentration of microbial biomass, t is time, u is specific growth rate. There are different growth rate for different microbes. Not it's constant. Depend on their environmental conditions. Depend on suppose if we using two ages spread. One is old culture from, and another is young culture. Condition providing same. The young culture will grow faster. So there the specific growth rate of the same species will be different in these conditions. If we are using a yeast and in another condition we are using bacteria, here also growth rate, specific growth rate will be different. Now the third stage is the stationary phase. Stationary phase here, the total number of viable cells remain constant. There is no cell growth, no increase in volume, size. Cell multiplication takes place but very lower speed. Since the media is mostly, nutrients are mostly depleted. Sometimes, suppose we are culturing for certain acidic metabolites, then that kind of acid will also released in the culture. That acid will also inhibit the growth of the organism. So here the rate will be 0. Now the fourth stage is the death or decline phase. Decline phase, here the exponential decrease in number of viable cells, growth decreases or ceased. But during a starvation condition, as we know that most of the microbes produce spores. So due to presence of that spore, OD will show optical density will show like higher, and it's the final deduction of the mathematical calculation through integration and differentiation, that is dx by dt is minus adx. AD is the specific death rate. Now, in batch culture, if we plot the curve graph, then it will be a straight line. It should be a straight line. But sometimes this, due to mu, which is the specific growth rate, this differs. This straight line differs, and organisms grow at their maximum specific growth rate, mu max, which is different for different microbes, and productivity in batch culture will be greater at mu max, and the improved product output will be achieved by increasing both mu and biomass concentration. If mu will be higher, product will be formation will be higher. If biomass concentration will be higher, product formation will be higher. Now second type is the fed batch. Fed batch culture is designed to keep the media or the cell mass in exponential phase only. So at the end of the log phase or in the beginning of the stationary phase, without removing cell, we add the medium, fresh medium containing the same nutrients. This this method is especially suited for cultures in which high concentration of substrate or inventory is needed to cell multiplication by biomass formation. And in such situations, substrate can be fed at low concentration to achieve cell growth. This is also used for the production intracellular products to achieve intracellular products, because certain metabolites are produced intracellularly during the fermentation process, and certain metabolites are produced outside in the broth. So for the intracellular product we use fed batch. This is two type: variable volume fed batch, another is the fixed volume fed batch. In variable volume we add the nutrient and which is due to this increasing volume increased, but sometimes it will also find that concentrated solution added, and due to this also volume increased, but you have to keep it that only since we are adding their medium nutrients, so volume is increasing, so volume is changing here. Another is fixed volume. Here concentrated solution we added, so volume remains fixed. Now there are growth kinetics is the formula of this process is biomass at after time t, whatever the time depends on, v will be equal to x0 biomass at the initial condition, or when the fermentation process was started, or we can say that inoculum concentration. Y is the yield factor. Yield factor is the gram biomass produced per gram substrate consumed, which is measure of efficiency of conversion of any one substrate into biomass. It also depend on rate, growth rate, pH, temperature, limiting substrates, and it's also different for different organisms. It is variable, not fixed. So we should have to keep in this mind that another is the fixed volume. Fixed volume, this is the rate is equal to substrate feed rate, and rate is the multiplication of substrate feed rate and yield factor. If yield factor will be higher and substrate feed rate will be higher, then the rate will be higher. If any one factor from these two, substrate feed rate or yield factor will be lower, then the rate will also become slower. But here we added, this is the first equation during the batch culture. dx by dt rate is equal to Unx. Rate depends on the specific growth rate and the biomass concentration. So when we substitute this value in here, then the final formula we get, that is the mu x is equal to gy, or g is equal to mu x by y. So keep it in liquid so that it may be useful sterilized. Now the third one is the continuous culture. Continuous culture, as the name indicates, that the bacterial culture maintained in exponential growth phase for long period of time. Here, how we do this? We do this by adding the nutrients after certain time period, and we draw also we can withdraw the product, so the volume also remains more or less constant, or we can fill it up to the optimum level. Here you see the continuous bioreactor. One is the source for fresh medium from the reservoir. Here already ready made medium, means the media is already prepared, already decayed, is kept separately, and after a certain time, here suppose we remove about 20 liter, we added the same amount here, 20 liter, so that the biomass, the cell, will remain in exponential phase, so that the product should be high, product formation rate will be higher. So this is the basic, continuous culture. Now, since we add here medium, means we are diluting here, so the rate of product formation will depend on the specific growth rate and the dilution factor both. If dilution factor will be higher, means the rate of formation of product will be lower. If this dilution factor will be lower, the rate of production of product formation will be higher. A specific growth rate is different for different microbes. If a specific growth rate and biomass concentration will be higher, obviously it will be higher. Okay, so another thing is that mu is equal to D. Then steady state will be achieved. Means a specific growth rate is exactly similar to the dilution rate. जिस टाइम में प्रोडक्ट माइक्रोब्स का ग्रोथ रेट इंक्रीज कर रहा है, उसी टाइम जितना टाइम उसमें लगा उतना ही टाइम में हम डाइल्यूट कर ले रहे हैं. दूसरा सेकंड कंडीशन इज दैट स्पेसिफिक ग्रोथ रेट इज हायर देन डाइल्यूशन रेट. देन व्हाट विल हैपन? देन since dilution is smaller, the specific growth rate is higher, means the microbe or the desired organism will consume larger amount of substrate. Okay, so growth rate will be slow until the equal, and opposite of this, if specific growth rate is smaller and dilution will be higher, then what will happen? The amount will be the amount utilized, therefore growth rate will increase until it is equal. तो यहाँ पर क्या होगा कि डाइल्यूशन ज्यादा हो गया, सबस्ट्रेट कंसंट्रेशन बढ़ गया, लेकिन उसको उतना यूज्ड अप कर ही अपने रेट पे तो कर ही रहा है. जो है वो आपको स्पेसिफिक ग्रोथ रेट है, इससे वो आपको अपने कैपेसिटी के अनुसार उसको यूज्ड अप कर. नाउ chemostat is the bioreactor through in which we do continuous culture. So accumulation of toxic substance thereafter. So basically there are only three things. These equations you have to keep in memory. Now, criteria for medium forms. The criteria should be common thing is that we will decide that the rate of product formation will be higher. Thereafter, the cost should be product. Thereafter, it should be available throughout the year. Minimum problem during making the media or sterilization. Thereafter, during downstream processing, these processes we can do easily, so that the product we can find the product in either solid form or liquid form. There are certain parameters for medium. First is the pH. pH changes during the process of fermentation due to release of different kinds of metabolites depend on the type of product, which is maintained by CO2 bicarbonate. Thereafter, osmolarity, which is also maintained by sodium chloride. Trace element we add there: iron, zinc, copper, magnesium, molybdenum, selenium, vanadium. But these are already present in the other medium components as impurity, because whenever we find on a medium box there is not 100%, sometimes 98% pure, 99% pure, 97% pure. It's not the constituents. Next is the protein-free medium. If protein will be in large amount, means flocculation will be higher. If flocculation will be higher, then we have to add the anti-food agent, alcohol, octyl, decanol esters, fatty acids to reduce the flocculation, so that the rate, because this alters the rate of formation of product, which is achieved using these chemicals. They destabilize protein fields by reducing the surface tension through hydrophobic breach, energy displacement of the absorbed protein, and rapid spreading on the surface of the film. Certain other non-nutritional chemicals are also added. This is to prevent from mechanical searing due to continuous movement of the shaft. Serum-free medium. Serum is the content of several kinds of nutrients, vitamins, amino acids. So this is most helpful. Thereafter, the rheology of the medium should be maintained. If highly viscous, if the medium becomes viscous, then we should have to minimize or keep it up to optimized level. There are certain inducers which induce the formation of the product. Every microbes need carbon source for their growth. There are the list of carbon sources for these for the production of these products. These microbes. Thereafter, nitrogen salts also are useful. Corn stick liquid, peanut granules, soybean meal. These are the cheaper, so that the product should be cost effective. Minerals are also like that. H2PO4, GC4. Precursors are the chemical which is directly incorporated into the desired product. Suppose we have to um, produce the individualistic acid. So cultured medium, there we have to add tryptophan. Tryptophan is a precursor of individualistic acid because the tryptophan already become incorporated in the individualistic acid structure. So these are the precursors which induce the formation of that particular product. Growth factors are also useful. Certain chelating agents, CDTA, citric acids are also added in. Inhibitors are used to reduce the byproducts, the rate of formation of byproducts. Suppose we want a particular product, but due to just like in the formation of penicillin, there is a formation of lysine also takes place. But here what we do, production of lysine, the rate of production of lysine we minimized using the inducer, so that the concentration of penicillin will be higher. There are certain enzymes and inducers, that here inducer will induce the production of that enzymes. Methanol has been used as energy source, cheapest energy source. So these are the parameters for industrially important microbes. The microbes should not react with the interior wall of the equipment. The isolate should be stable. The productivity of the isolate should be maximum. For the isolation of microbes for industrial use, there is a technique called gradient plate technique. In this technique, what we do, we have prepared the agar medium containing the analog and added 12.5 ml of molten agar in the petri plate and allow it to solidify at an inclined position, so that one side will be higher concentration of agar and another side will be lower, so that what will happen there a kind of gradient will be formed. Now after solidifying this, again we add same amount of molten agar medium and allow it to solidify at plane surface. Now since there is analog in the lower medium, in the bottom, so there is a gradient already formed, and now when we plate over here using the through bacteria, there will be the resistant bacteria will only go there. Suppose why analog? Suppose you have to you isolate urease containing bacteria. Okay. Then what we do? Then in the lower medium we add urea. If there is urea in the bottom medium and upper is nothing, there is only medium, and then now we take the sample or mixed culture and spread it over. Which kind of bacteria will grow there? Only urease containing bacteria, because that bacteria only can break down the urea. So we can easily isolate. Similarly, we can also isolate protease containing bacteria. In this condition, we add protein source, albumin in the bottom medium, and similar process repeated after 48 to 72 hours and find the colonies of that bacteria. Sometimes homokaryon and heterokaryons are also produced. Recombinant also used, technology also used, UV treatment. Thereafter, certain genetic manipulations are performed so that most efficient strain can be isolated. Now, how the production of citric acid takes place? What is citric acid? It is a weak organic acid found in citrus fruit. C first of all discovered, crystallized it in 1784, and thereafter it was discovered in Aspergillus niger. It was found that it is a producer of citric acid. Similarly, we prepare medium using carbon source as molasses, oxygen concentration and nitrogen source. Here, citric acid production takes place under nitrogen phosphate limited condition, but here for initial growth we add there ammonium nitrate or nitrogen source, any other nitrogen source in limited amount, in very small, so that the growth will start. Temperature 30 degrees in batch culture or fed batch culture. Thereafter, all the conditions are as usual. Excitation will be 50 to 100 RPM to avoid searing or damage. After completion, harvest the culture broth by filtration. Mycelium will become separate and the broth will become separate. Added by calcium hydroxide in the broth. Again, to neutralize the calcium carbonate added, and finally we find citric acid here. Sulfuric acid are added to crack the calcium precipitate form. Thereafter, this sulfate was washed away and the liquid one was contained in citric acid. In this way, we recover the citric acid in solvent form, crystals. As we know, the ethanol production is very old technique, image, which is released by the yeast, most important enzyme for the production of ethanol. Another strain is the Zygomonas mobilis, which also used during the fermentation process. There are several steps: is the grinding, cooking. Cooking to achieve grinding is to do we do grinding only to increase the surface area, so that the activity or reaction will be more. Thereafter, cooking to maximize the enzymatic activity and minimize the cost. So here starch is hydrolyzed into fermentable sugar, dextrin, and simpler form. This final is the to convert it into simpler form. Now, thereafter the fermentation. It presents fermentation in the fermenter. For stress management, there are certain stress factors for yeast, such as sugar concentration, ethanol temperature, micronutrients. We do sometimes saccharification, which is the breaking the complex carbohydrate into more. Now, are you understanding? Hello. Now come to the production of tetracycline, one of the oldest antibiotic, which is produced, which is a protein synthesis inhibitor in bacteria. It is produced by actinomyces, streptomyces, orifices, and benzyl thiocyanate acts as precursor for the production of chlorotetracycline and tetracycline. There are certain sources like nitrogen source, carbon source, calcium carbonate, NaCl, and the medium constituents are added. After completion of the incubation period, further downstream process will be performed, and then the tetracycline will be produced. Similarly, streptomycin production is also inhibitor of protein synthesis. Bind to 30S ribosomal subunit, and mRNA misreading started. There are nitrogen source, soybean meal is used as glucose used as carbon source. Similarly, there are more than 10,000 strains has been till date discovered, and antibiotic has been discovered, but all are not well familiar. But we see literature and review, it will be observed. Now, the lysine formation is amino acid. There are two main pathways. That is one is the diaminopinylic acid pathway, another is the alpha amino adipate pathway. The strain used are Aerobacter aerogens. Here, sometime another strain is also producing. These are the Corynebacterium, Brevibacterium. The most important lysine secreting strains are Corynebacterium glutamicum, Brevibacterium flavum, flavum, Brevibacterium lacto-fermenter. Protoplast technology has been used to improve its efficiency. The source, carbon source commonly used are cane sugar molasses, acetate, ethanol, alkane, and gaseous ammonia or salt are used as nitrogen source. Growth factors are also added for the production of lysine. The main mechanism behind this is the D-alpha amino caprolactam is racemized using Aerobacter AB, that is L. Dextro से इसको लीवो सेम चीज है, फॉर्मेशन चेंज है. उसके बाद हाइड्रोलाइसिस के थ्रू ये लाइसिन कन्वर्ट करता है क्रिप्टो थ्रू क्रिप्टोकोकस species. Now, the medium constants are there, but it depends every time because in theory we find something different, but when we go to the lab and doing the same work, we have to modify according to our need. Now, similarly, glutamic acid is a very important flavoring agent, most abundant amino acid present in bacterial cytoplasm, produced by Corynebacterium glutamicum through TCA cycle. Addition of biotin and fatty acid derivative results in increased production of glutamic acid. This process is carried out in fed batch type of culture. Folic acid can be added to increase glutamic excretion. These are the important things which is related to this. Thereafter, corn steam liquor are also added in this medium, and genetically improved strain Bacterium lacto-fermentum are used to convert glucose to glutamic acid. Okay. Penicillin is discovered by Alexander Fleming. The source is the Penicillium notatum fungus. Penicillium chrysogenum is the more improved strain. It is also secondary metabolite. Tetracycline, all are mostly are the secondary metabolites. The main basic formula, basic chemical is the alpha ketoglutarate with acetylcholine A homocitrate, and finally glycine with penicillin. It can be produced can be collected. Thereafter, the phenoxyestic acid, the most important thing is that acts as and glucose, the carbon source substrate. Thereafter the pH say 5.5 process through which it's performed. The most important thing is that phenoxyestic acid acts as the precursor. So it's all about the fermentation, microbial fermentation, but there is certain things which we might relate over. If you may not understand, then I can take another class. So this was just big class screen. Any question from any side? Hello?
Yes, sir.
Yeah, please ask. Hello?
तो कोई क्वेश्चन नहीं है.
Oh.